Hey guys, what's going on? In today's ML4all tutorial, we'll walk you through the fascinating world of natural language processing. In this video, we're going to cover everything from the basics of NLP to advanced concepts like large language models. We'll explore how these technologies are revolutionizing the way we process and analyze massive amounts of unstructured text data. So let's dive right in and discover how NLP is powering applications like translation, autocorrect, chatbots, and sentiment analysis. Alright, so what exactly is natural language processing? Well, at its core, NLP is all about teaching computers to understand, interpret, and generate human language. It's the technology that allows your phone to understand your voice commands or your email to suggest automatic replies. Now, the applications of NLP are pretty much everywhere in our digital lives. Think about it. When you're using Google Translate, that's NLP in action. When your phone corrects your typos, yep, that's NLP too. Chatbots, virtual assistants, even those sentiment analysis tools that companies use to gauge customer opinions, all of these rely on NLP. But here's the thing. Natural language is messy, ambiguous, and context-dependent. That's what makes NLP such a challenging and exciting field. We're not just dealing with structured data like numbers in a spreadsheet. We're dealing with the complexities of human communication. Now that we've got a handle on what NLP is, let's talk about how we actually process text. The first step is usually text segmentation, breaking down our text into manageable chunks. This could be sentences, paragraphs, or even individual words. Once we've done that, we move on to tokenization. This is where we break our text down into individual tokens, which are usually words or subwords. After tokenization, we often remove what we call stop words. These are common words like the is and the don't carry much meaning on their own. By removing them, we can focus on the words that really matter. Then we have techniques like stemming and lemmatization. These help us reduce words to their root forms. For example, running, ran, and runs would all be reduced to run. This helps our models understand that these words are related even if they're written differently. Once we've processed our text, we can start applying machine learning models to it. One of the simplest and most effective models for basic NLP tasks is naive Bayes. It's great for things like spam detection or simple text classification. Despite its simplicity, it can be surprisingly effective for many tasks. But as our NLP problems get more complex, we need more sophisticated models. This is where large language models or LLMs come in. These models use what's called a transformer architecture. Without getting too technical, transformers allow the model to understand the context and relationships between words in a way that previous models couldn't. This is what powers advanced applications like ChatGPT or DeepSeek. These models can generate human-like text, answer questions, and even write code. It's pretty mind-blowing stuff if you ask me.